compressor housekeeping practices. That is, if our compressor is healthy, utility compressor is healthy, automatically the compressor house also will be healthy. And as such, the existing practices call for almost, it's like house warming practices, and the compressor house is very much warmer than the outer ambient surroundings. How this can be rectified and how the energy savings can be achieved by sustainable healthy working of the compressor, that is what I wanted to discuss here. Thank you. So the reasons why your compressor house is hotter than the surroundings, because the compressor rejects the heat of compression. The HOC rejection from the air compressor is around more than 70%, and the exhausted air from the compressor hood needs to escape out easily and smoothly out of the compressor house, but that is not happening now. This makes the air receiver very much hotter, and automatically the air also becomes hot, though it is cooled by the refrigerator dryer, but still the air that is going to the process also gets the air intake is getting hotter and delivery also getting hotter. Overall system health is deteriorating. The refrigeration dryer needs to remove the heat from the compressor further by cooling. That is, 3 stages of moisture removal is there in the compressed air. One at the post air cooler within the hood, then comes the refrigerator dryer, then comes the air receiver, then comes the refrigerator dryer by cooling. So the water removal needs to happen in stages, and that's why we always say compressor is, if we visualize, the compressor is like a submersible pump that is working in air. The submersible pump down under the earth, when it works, it needs both water to suck as well as the water to surround so as to keep the pump cool as such. Likewise, our air compressor, screw compressor utility also needs air to suck for its air intake, and as well it needs air, surrounding air, to cool the compressor so that the heat transfer from the compressor heat exchangers like post air cooler etc. needs to happen as it. The cool surrounding air at the intake, and that is what the free air delivery that is talked by the compressor OEMs here. Normally, the compressor has delivered to the machine is only a fraction of what is produced at the compressor end. Almost the delivered air is around 10% at the point of usage, whereas the heat losses, HFC, heat of compression losses at the compressor end is around 60%, 60 to 70%, and the losses in generation, treatment and distribution and misuse around 30%. So we have to see how to improve the working of the compressor house in such a way that it definitely helps to sustain the health of the compressor, and as well as the compressed air treatment, as well as the distribution further to the process as such. So what are we monitoring in our compressed air compressor utility? So this monitoring, are we doing it locally or with remote alarms or remote monitoring, or through 485 232 interface to the main plant computer, or the operator needs to know, apart from the maintenance, the production also needs to know the compressor is healthy enough to operate for the process as such. So the air receiver temperature, see, these are all the temperature, these are all the monitoring or the indications which I am suggesting here needs to be done for the maintaining the healthy working of the compressor as such. So air receiver temperature, normally it's around ambient temperature, probably around 5 degrees above also, but that also, once the temperature goes higher and higher, that shows that the post air cooler is not working. So that will give an indication whether the compressor is not healthy, with an alarm also. Then the zero air loss drain valves at the compressor end, at the moisture separator, at the dryer and at the receiver. These also needs to function correctly so that the water ingress need not be there when it comes to the process. Then the compressor loaded and unloaded KW and the KWH hours and its trend also, the load and unload hours. The refrigerator dryer in and out temperature, to know the refrigerator dryer is functioning well and removing the water from the compressed air, as well as keeping the health of the compressor air dry, cool and dry as such. The pressure drops from the compressor to the main header in the compressor house, that needs to be seen through the pressure gauges and digital, either analog also. The air intake filter pressure drop, it can be a local indicator with a remote alarm. Though some of the OEMs have given it, but still from the user point of view, let us have a air intake filter indicator along with a remote alarm also, just to know the compressor will not be manned all the 24 hours of the day. So the remote alarm can definitely help you to immediately attend to the compressor air intake, the starvation of air intake as such. The thermal imaging of the compressed air piping inside the compressor house will definitely show where all the possible chokes or the possible drop in flow in the compressed air lines, and the sonic imaging definitely it helps to see the air leaks that is happening in all the pipes and tube joints as such. This is what I mentioned, the compressor housewarming practices. See, once the heat of rejection, the HOC of the compressor heat of rejection is around 70%, that needs to be evacuated well with a easily expanded exhaust duct that needs to come out, that needs to be short, and it needs to be duct, it should be insulated as well, and it should come out easily out of the compressor house. Once here in one of the case study where we have done the energy audits, we found the compressor duct was just made as a chute. It de-rated the compressor post air cool this fan. Automatically the compressor is put to more of strain and more of load as such. So, and also the compressor house also gets hotter because of the duct being not insulated as such. So the duct needs to be expanded, it needs to be very short, and it needs to be insulated also outside, so that the heat radiation from the compressed air duct is not disturbing the compressor house as such. The compressed air usage needs to user as well as the usage needs to know the ambient surroundings, and whatever the variation is there in the moisture in the ambient air, say you can see for a 30 degrees centigrade for every 1000 kg water vapor per hour, you can see the relative humidity at 50% and 80%, it's almost the difference is huge. At 100% you can see. See, these are all the relative humidity which the compressor has to face at its air intake. In the daytime and night time, the variations are more. So the compressor efficiency also with respect to the suction temperature and RH, definitely it matters more, and definitely in place to place the compressor, whatever the OEM has given as the FAD, they have given the FAD as per their own criteria. They have given they have benchmarked the criteria and they have given their FAD, but it is for the user to just check the compressed air flow at the required pressure for the process, and what is delivered and what is as per the norms as such. Here to start with, see, I am just going by from the compressor end at the air intake. Normally the compressors above 50 HP, let us say all the screw compressors, they need a air intake Pascal gauge. It can be just a Magnahelic gauge to just monitor around say 500 Pascal or 1000 Pascal or 3000 Pascal. See, whatever the pressure, the filter getting choked, that Pascal needs to be shown well in the pressure gauge as such. This type of yellow and green bulb that is normally fixed in the air intake of the compressor, that doesn't help. Some of the OEMs have done that, but now the trends are changing that every OEM needs to put definitely a digital Pascal gauge or an analog Pascal gauge with a remote alarm, so that they know what is the air intake pressure drop that is happening at the compressor, and that will definitely lead to the compressor efficiency and the flow drop also. In some of the compressors, the OEM also gives on the console the air intake delta P, but it is measured in terms of bar, whereas bar means it's almost 1 lakh Pascal is 1 bar. So if it is monitored or displayed in Pascal, definitely the user will be tempted to take more of attention to know the air intake filter pressure drop, and definitely he can take steps to how to reduce it. The compressed air, definitely especially at the compressor at the air intake, visualizing the ambient surroundings, harsh surroundings at the compressor end, at the compressor house, compressor feels definitely starved air delivery at the suction instead of free air delivery. So we can think of adding this V-type micron filter as a mesh filter to start with, and a less than 10 micron filter at the second stage, where with a gap in between the first filter and the second filter. And routinely the maintenance user of the compressor, they always clean these filters regularly and keep an active spare also, so that the compressor main air intake filter does not get choked very often as such. These are all the pre-filters, two-stage pre-filters I am trying to suggest here. Then comes the piping inside the compressor house. What all that is seen, we can see it in the thermal imager also. It can definitely use to detect the hot spots in the running compressed air system as well as it. Even in the process system also it is used. Normally in the traffic you used to say it's a slow in and fast out for any of the pipe joints, especially the elbow joints or the T joints, where you need to have 45 degrees directional conjoining joints towards the air header flow, towards the compressed air header. See, you can see on the left bottom, this type of joints need to be used for each and every compressor to the main header as such. If you have a elbow joint and that to a sharp T extra, these need to be avoided, and if it is to be reworked, it is better to rework now and make the joints longer bend and conjoining joints also at the compressor house. The longer these are all the observations what we do in our energy audit case studies, we are sharing it to you now here. The long bends at the dryer to the receiver, and this, see, almost 45 degrees direction connection with a conjoining pipe that is taken like this, definitely it will see to it that the flow of the compressed air in the piping, especially on the T junctions or on the L junctions, will be very smooth than a sharp T or a sharp L bends as such. And the piping, what we are supposed to have the compressed air for the given compressor, what is the compressed air header piping. Normally for a you can say 1 inch pipe we are using up to a compressor FID of 35 CFM, and it's around say for 50 HP you are seeing almost you need to have a 2.5 inches compressed air header piping. And say if you want to have say 110 kilowatt compressor like that, it takes almost 700 CFM plus. You need to go between 3 inches to 4 inches depending on your condition. That is the higher the sizes, that is the size that is slightly above the rated FID of the compressor, definitely gives a smooth flow of air, compressed air inside the compressed air network. And the pressure gauges need to be installed across the refrigeration dryer as well as in the filters, so that you know the pressure drop that is happening when there is a full flow of compressed air from the compressor to the process end. The pressure drops or the temperature drops, these need to be seen across the refrigerator dryer, across the filters, so that you know what is the allowable drop and how much it is happening here when the compressor is in full flow giving to the process as such. If you see the thermal imaging, it shows the compressed air that is separated from, that is the moisture that is separated from the compressed air in stages at the moisture separator, and next at the air receiver, and then by cooling at the refrigerator dryer. Here you can see the temperature is entering at compressed air temperature is entering at 44 degrees and coming out at 35 degrees. So the dryer is effective working of dryer can happen only if there is an appreciable temperature difference across the compressed air flow between the inlet and the outlet of the dryer. This we have observed during our audits right from 2012 onwards. Coming to the loading of the compressor, I will just come one second. Always it is prudent to size the compressor, to have one compressor as a big compressor as a base load compressor and the other compressor as a smaller size for modulating. Normally the compressor in general is healthy if 60 to 80% loading region is there. Definitely it gives a excellent CFM per kilowatt. And the compressor becomes inefficient if it is operated less than 50%. Let us say the compressor almost it takes around unloaded pressure the kilowatt itself around 40% of the rated power. So if it is operated less than 50% or if it is operated more than 100% also, the efficiency automatically drops further. So it is always sustainable to run the compressor at 60 to 80% in general. Here during our audits we came across a case study where one 75 kilowatt machine, it's supposed to deliver around 500 CFM. It was just almost, you can see the zigzag variation of 50 kilowatt to 90 kilowatt, 40 kilowatt variation was there, 40 kilowatt variation was there 90 times in 30 minutes, almost 3 times a minute, due to the artificial pressure drop from the compressor to the receiver and to the before it goes to the process at the compressor house. So what we have suggested them is to just relocate the pressure control sensor from the compressor hood to the air receiver. Automatically the energy saving also is achieved, and this zigzag straight away came down to non-pulsating, it became totally non-pulsating, it gave a steady airflow. So this is what we want. Each and every compressor, the pressure control sensor need to be there in the air receiver at the subsequent to the compressor. That will definitely give a non-pulsating steady, it will be sensing the pressure correctly, and it will deliver also the compressor cut in cut out also, it will be delivered smoothly with no zigzag like this. Screw compressors come in a hood with post air cooler, but some of the tropicalized climates call for even the post cooler can be taken out of the screw compressor and kept outside also, because it definitely improves the heat transfer of the from the post cooler air cooler after cooler to the ambient outside. If it is inside the compressor hood, it gets derated. So you have to routinely maintain the compressor within the hood also, you have to maintain the compressor. That is first point. And the second point is, logically the post air cooler is outside. It is a better suggestion if there is a place in the compressor house. Also, you are installing the zero air loss valves at the post air cooler, at the moisture separator, at the air receiver and at the refrigeration dryer. Each and every zero air loss valves, if it is fixed with an online cleanable Y type strainer at the incoming of the zero air loss drain valve, definitely it can be cleaned daily, so that the strainer can be cleaned daily, online cleanable, and definitely the zero air loss drain valve will definitely function as a foolproof valve, and definitely the water will not be ingressed into the compressed air system at all. The moisture separator needs to be fixed. Many of the OEMs have fixed the moisture separator outside the compressor hood. That is what it is wanted now. And if it is not done, the user can definitely install of his own, because the moisture separator first removes the first major amount of water ingress that is there from the compressed air, apart from the post air cooler, then the moisture separator, then it comes to the receiver, where by the say by the Joule Thomson effect, the compressor definitely will come to the receiver at a say of 1000 or 2000 liter higher capacity. There the compressor air comes to settle down in the air receiver, and thereby the water can be received through the zero air loss drain valve as such. Monitoring, see, monitoring of the compressed air pressure, the flow and the temperature, everything is important, and the dew points, apart from the dew points, the airflow, the temperature and the compressed air pressure, everything is important during our daily checks, including the hour meter indication, the discharge temperature, the load and unload pressures, air filter plug, etc. The moisture outlet at the running condition, the moisture ingress is not there at the outlet. These are all the things routinely to be checked, thanks to the LG checklist here as such. The header flow meter, this is what I wanted to mention specifically. It is a must for any of the compressors, say above 50 HP, to find the average watt per CFM at the delivered pressure to the process. The OEM, the compressor OEM needs to check his compressor FAD during the installation with his meter to locate at the compressor delivery before the air receiver. But normally it is the user's mandatory need to install this flow meter after the dryer. The compressor flow meter also needs a cool dryer only. So if it is after the dryer with a 20 dia upstream and downstream dimensions, if it is fixed on a straight line, it is straight under this one piping, where the flow meter definitely will monitor the cool dryer, and definitely it will give the kilowatt per CFM. That is what the user is more interested to achieve as such, and he wants to sustain the kilowatt per CFM. See, the compressor OEM, whatever he gives as the FAD kilowatt per CFM, and the user's kilowatt per CFM need not match as such, because this condition at the FAD criteria is different, whereas the user condition at the delivered temperature and pressure is different. So, but the user needs to see whether it is as per the norms, whether it is say around 0.15 kilowatt per CFM or 0.13 kilowatt per CFM or 0.17 kilowatt per CFM, that needs to be checked, and that needs to be sustained from the date 1 of installation of the compressor to the end of the till the period of the compressor running as such. This graph I just wanted to highlight here. When the air intake filter gets choked, normally the air intake filter, when the fresh filter is fixed on the compressed air within the compressor, it will be around 100 to 200 pascals, and the air intake filter got choked to 2700 pascals. There you could find there is a 13% difference in the volume delivery by the compressed air delivery flow at the delivery. So this is a definitely the user needs to either install in parallel air intake filter, because we have doubled the size of the dryer after the compressor. So one way to go for doubling the air intake filter and keeping it parallel at the incoming of the air intake of the compressor. Otherwise, routinely cleaning the air intake filter with a 2-stage pre-filters in such a way that you always try to maintain less than 500 pascals at the air intake when you are measuring through your digital Pascal or analog Pascal gauge. So less than, the less amount of Pascal, less amount of choke that is there at the air intake, definitely the compressor delivery flow will be near to 100%. You can see this is the case study which you have taken thanks to Sinthan, this one. All these things I have just covered. So the compressor, basically compressor is a dynamic process variable in the utility side. All the at the compressor intake, at the compressor house, at the compressor treatment, everything needs to be checked, maintained well, as well as checked regularly, routinely, so that we can sustain the kilowatt per CFM for longer years, more than say 1 lakh hours. The compressor element is stated to give the utility life. Till that hours, definitely it can give a kilowatt per CFM, sustainable kilowatt per CFM. All these observations, all the case studies I have discussed in my energy savings in compressor system utility book, as well as in the practical guide to energy conservation and management book. You can go through it, and if you are able to achieve more of energy savings in your compressed air and other utilities, kindly you can share it to others. Thank you. Thank you. Thank you.